You've seen them everywhere. JPEG, PNG, GIF, WebP, they're all image files. They all show you pictures. So why do we need like 10 different ones? Here's the thing. Every single format exists because the last one couldn't do something important. One can't handle transparency. Another makes your photos look terrible. A third one refuses to be anything smaller than enormous. By the end of this video, you'll know exactly which one to use and why. JPEG. It's the image format you've used 1,000 times without thinking about it. JPEG was created in 1992 by the Joint Photographic Experts Group. It exists for one purpose: making photos small enough to actually share. The way it works is clever but ruthless. JPEG compresses images by throwing away details your eyes won't notice. Think of it like summarizing a novel. You keep the plot but lose some sentences along the way. That's called lossy compression. The number that matters here is the quality setting, from 0 to 100. Somewhere around 80 to 90, photos look basically perfect at a fraction of the original size. Below 50, things get crunchy fast. Use JPEG for photographs and anything where file size matters more than perfection. It's awful for text, logos, or anything with hard edges. The biggest mistake people make is resaving JPEGs over and over. Every save compresses it again. It's like photocopying a photocopy. Each generation loses a little more detail until your image looks like it was faxed in 1997. PNG. This is the format people reach for when JPEG falls apart. PNG stands for Portable Network Graphics. It launched in 1996 as a free replacement for GIF after a licensing mess. Where you'll find it is everywhere: logos, screenshots, icons, UI elements. PNG does something JPEG simply cannot. It supports transparency. That means you can have an image with no background, floating cleanly over any color or page. It's like cutting something out with perfect scissors instead of tearing the whole page out of the magazine. PNG uses lossless compression. Every pixel stays exactly where you put it. The trade-off is file size. A PNG of a photograph can be 5 to 10 times larger than the same image as a JPEG. That matters for web performance. Use PNG when you need sharp edges, transparency, or pixel-perfect accuracy. Skip it for large photographs. The myth that won't die is that PNG is always better quality. Technically true, but for photos, the file size penalty almost never justifies it. GIF. Everyone argues about how to pronounce it. The creator said, GIF. The internet collectively said, absolutely not. GIF stands for Graphics Interchange Format, and it's been around since 1987. That makes it older than most people watching this. A GIF is basically a flipbook. It stores multiple frames in one file and loops them endlessly. That's why every meme reaction lives in this format. But here's the catch. GIF only supports 256 colors per frame. That's it. Modern screens display millions. So GIFs look grainy, dithered, and honestly, kind of rough by today's standards. File sizes balloon fast too. A 5-second GIF can easily hit 10 megabytes. Use GIF for short, simple animations when universal compatibility matters. For anything longer, you want a video file. An MP4 will be smaller and look dramatically better. If you're still sending GIFs in your group chat, I respect the loyalty, but the format is running on fumes at this point. BMP. If you used a Windows PC in the 90s, you know this one. BMP stands for bitmap. It's Microsoft's original image format, and it does absolutely nothing clever. A BMP file stores every single pixel with its exact color value. No compression, no tricks, no shortcuts. It's like writing out every word of a 3-hour conversation instead of just the highlights. The result is absurd file sizes. A simple 1920 by 1080 image in BMP can land around 6 megabytes. The same image as a JPEG would be maybe 200 kilobytes. There's really no practical reason to use BMP today unless very specific software demands it. Some legacy programs and embedded systems still expect the format. The common myth is that BMP equals better quality. It doesn't. It just means uncompressed. A PNG gives you identical lossless quality with dramatically smaller files. BMP is a museum piece. Respect what it did for early computing, then leave it in the past. TIFF. This is the format that professionals quietly rely on, while everyone else argues about JPEG versus PNG. TIFF stands for Tagged Image File Format. It was developed by Aldous back in 1986 and later absorbed by Adobe. You'll find it in print shops, medical imaging systems, and serious photography workflows. TIFF is the armored truck of image formats. It supports lossless compression, multiple layers, and incredibly high bit depths. We're talking 16-bit or even 32-bit color channels. That's a canvas with millions more shades than your monitor can physically display. The file sizes reflect all of that. A single TIFF can easily hit 50 to 100 megabytes or more. Use TIFF when you need maximum quality for print or archival work. Never put one on a website unless you hate your visitors. The mistake people make is assuming TIFF is overkill for everything. For professional print production, it's often the only format that preserves enough data to get the job done right. SVG. This one is completely different from everything else on this list. SVG stands for Scalable Vector Graphics. It's not made of pixels at all. An SVG is actually code, a text file that describes shapes, lines, and curves using math. Think of it like a recipe versus a photograph of a cake. The recipe can produce any size cake. The photograph is stuck at one resolution forever. That's why an SVG logo looks razor-sharp on your phone and on a highway billboard. It scales infinitely with zero quality loss. The key thing to understand is that there are no pixels and no resolution. File sizes stay tiny for simple graphics. A logo as SVG might be 2 kilobytes. Use SVG for logos, icons, illustrations, and anything geometric. It's completely useless for photographs. The biggest mistake is trying to convert a photo into SVG. You'll get a bloated, ugly disaster. SVG handles shapes. Let JPEG handle the photos. They have different jobs and that's fine. RAW. If you own a dedicated camera, you've seen these files and immediately been annoyed by them. RAW isn't actually one format. It's a whole category. Canon shoots CR3 files. Nikon uses NEF. Sony goes with ARW. Every manufacturer does their own thing. A RAW file is the unprocessed data straight off the camera sensor. No sharpening, no color correction, nothing baked in. It's like getting flour, eggs, and butter instead of a finished cake. You do all the baking yourself in software like Lightroom or Capture One. These files are huge, often 25 to 80 megabytes each, but they give photographers complete control over exposure, white balance, and color grading after the fact. Shoot RAW if you seriously edit your work. Shoot JPEG if you want something ready to post immediately. The common myth is that RAW files are the real photo. They're actually just sensor data. Without processing, they look intentionally flat and dull. The magic happens in the edit. WebP. Google built this in 2010 and then spent years convincing everyone to actually use it. WebP was designed to replace both JPEG and PNG on the web. It supports lossy compression, lossless compression, transparency, and animation, all in one format. It's a Swiss Army knife that genuinely does everything pretty well. A WebP file is typically 25 to 35% smaller than a comparable JPEG. With transparency, it crushes PNG on file size. The good news is that every major browser supports it now. Chrome, Firefox, Safari, Edge, all on board. Use WebP for websites and apps where page speed matters. The catch is compatibility outside browsers. Some older editing tools and social platforms still stumble on it. The common mistake is ignoring WebP because JPEG works fine. It does, but WebP does the same job with less bandwidth. If you build anything for the web, this format saves real money on hosting and load times. HEIF. If you've taken a photo on an iPhone in the last few years, you've already used this without knowing it. HEIF stands for High Efficiency Image Format. Apple adopted it in 2017 with iOS 11. It uses the same compression technology behind modern video codecs like HEIF. That's like giving your photos the same efficiency tricks that keep streaming video from buffering. HEIF files are roughly half the size of equivalent JPEGs at the same visual quality. They also support 10-bit color, depth maps, and image sequences in a single file. The problem is compatibility. Windows took years to add proper support. Many web platforms still silently convert HEIF to JPEG on upload. Use HEIF if you live in the Apple ecosystem and care about storage. Just know that sharing outside that world can get messy. The myth is that HEIF is Apple's format. Apple didn't create it. The MPEG group did. Apple just adopted it most aggressively. Drop your favorite image format in the comments. I'm genuinely curious what you all actually use day to day. AVIF. This is the newest serious player, and it's genuinely impressive. AVIF is based on the AV1 video codec from the Alliance for Open Media. That alliance includes Google, Netflix, Amazon, and Mozilla. AVIF emerged around 2019, and browser support has been growing steadily since. The compression results are remarkable. AVIF images can be roughly 50% smaller than JPEG at comparable quality. They support HDR, wide color gamut, transparency, and both lossy and lossless modes. It's basically WebP's more talented younger sibling who showed up and made everyone nervous. The downside is encoding speed. Creating AVIF files takes noticeably longer than JPEG or WebP. That matters for servers processing thousands of images per hour. Browser support is solid, but not completely universal yet. Use AVIF when cutting-edge compression and visual quality both matter. The mistake is assuming it'll replace everything overnight. Format adoption takes years of slow, boring infrastructure work. But the direction is clear. AVIF is where image formats are heading next. So we've traveled from JPEG's good enough compression all the way to AVIF's bleeding-edge efficiency. We met the transparency hero, the ancient flipbook, the uncompressed fossil, the professional tank, and the shapeshifter made of pure math. Every single format exists because someone looked at the last one and said, "We can do better," and honestly, they were almost always right. What image format do you actually reach for most, and have you made the switch to WebP or AVIF yet? Hit like if this cleared things up. Next video, we're breaking down every video codec in the same way. Same confusion, same story, even higher stakes. Click the video on screen right now.